Every day, all around us, objects start moving, stop moving, speed up, slow down, or change direction. But what truly causes these changes? And why do some objects stay perfectly still until something disturbs them? Today, we're going to uncover one of the most important ideas in physics, Newton's first law of motion. Let's begin with a simple idea. Long before Newton, people believed that you needed a constant force to keep something moving. If you stopped pushing, they thought the object would simply stop. But Galileo challenged this idea. He imagined and tested scenarios that completely changed the way the world understands motion. Picture this. A ball rolling down a ramp speeds up, then it reaches a flat surface and keeps rolling with almost the same speed, and then climbs another ramp. Galileo noticed something important. The ball always tries to climb back to the same height it started from. If friction didn't exist, the ball wouldn't stop at all. It would just keep moving forever on the flat surface. This was the first big clue. From this, Galileo discovered a new concept, inertia, the natural tendency of objects to resist changes in their motion. Heavy objects have more inertia because they have more mass. That's why pushing a bus is harder than pushing a small child. The bus has far more inertia. This idea led Newton to state his first law of motion, also known as the law of inertia. And here it is in simple language. If the net external force acting on an object is zero, the object will stay at rest or move at a constant velocity. That's it. No force, no change. Motion continues unless something external interferes. Let's break that down. If an object is sitting still, like a book on a table, it will stay still unless a net force acts on it. That could be someone pushing it, gravity pulling it off the edge, or friction resisting it. But as long as all forces cancel out, nothing changes. If an object is already moving, like a hockey puck sliding on smooth ice, it will keep moving in a straight line at the same speed unless an external force acts on it. In real life, friction eventually slows things down, but friction itself is that external force. If we removed friction completely, the puck would keep gliding forever. To apply Newton's first law, we often look at net force, the sum of all forces acting on an object. If the net force is zero, the motion doesn't change. If the net force isn't zero, then the motion must change. That means acceleration, slowing down, or changing direction. Imagine holding a weight above your head. Gravity pulls it down, but you push up with an equal force. These forces cancel out, so the net force is zero. That's why the weight stays still. Now picture an arrow being launched. The bowstring pushes forward with a strong force, and nothing significant stops it in that instant. The net force is not zero, so the arrow accelerates forward. This law also explains everyday experiences. When you're standing in a bus and it suddenly moves forward, your body wants to stay at rest. That's inertia, so you feel like you're falling backward. When the bus stops suddenly, your body wants to keep moving forward, which is exactly why seatbelts save lives. They provide the external force needed to stop your body safely. Newton's first law also helps explain modern safety designs. Older car seats didn't support the head properly, so in a rear collision, the body would move forward, but the head stayed behind, causing whiplash. Today, headrests keep your head moving with your body, reducing injuries. Simple physics, life-saving results. So to summarize the core ideas, objects at rest stay at rest. Objects in motion stay in motion. A constant velocity means the net force is zero. And when motion changes, whether it speeds up, slows down, or turns, a net external force must be acting. Understanding this law not only helps you solve physics problems, it helps you understand the world around you, from car safety to sports to why pushing a heavy couch feels so different from pushing a small chair. And now that you know Newton's first law, you're ready to explore the forces that actually cause changes in motion in the next lessons. Before you go, make sure to like this video and subscribe to the channel. Your support helps us create more clear, easy to understand physics lessons to help you succeed. Thanks for watching.